Pharmaceutical powder blends are typically not directly compressed. This may be due to a number of reasons, the primary being poor flowability resulting in inconsistent compression, limited ability to bind into a compact entity, low active API concentration resulting in challenges to develop a uniform dose. To address these challenges, a granulation step is commonly performed. Granulation involves the binding of smaller particles into larger granulates through aggregation mechanisms. These granulates are usually designed to have a similar granulate size distribution, and this greatly improves flowability. The elimination of fine powders is also an advantage when working with high-potent APIs. Granulation operations can be separated into two main types: wet granulation and dry granulation. Wet granulation. There are numerous types of granulators available, but one of the most common types is a single pot processor. In wet granulation, a solvent, usually water, is used to facilitate the agglomeration process. This wetting step is carefully controlled through adjustment of spray rate to avoid localized overwetting. Granulate characteristics are also achieved through application of high shear mixing using the main impeller and high-speed choppers. Following the completion of the granulation step, the SPP moves into a drying phase, whereby the solvent is removed to an acceptable level. Granulates can then be further homogenized via low shear milling, such as co-milling, following discharge from the SPP. Dry granulation. One of the most common dry granulation techniques is roller compaction. This technique involves the compression of a uniform dry blend into solid ribbons by two counter-rotating compression rolls. This compression step is carefully controlled by active control of the gap between the rolls and by modulating the roll force that is applied. The resulting ribbons are then milled in situ into uniform granulate. The key advantage of roller compaction is that no extended drying step is required, as with wet granulation. Additionally, this technique can be used for moisture and temperature sensitive powders. Dry granulation has some disadvantages, however. For example, throughput rate is relatively slow. Also, the blend must be sufficiently flowable in the first instance to ensure consistent feeding to the compression rollers.